want to use my postings to the full benefit, please subscribe the channel and enjoy earlier postings. Then only you can understand the subject fully. Thank you. I'm Ennemcien. I'm going to introduce Doppler effects in sound. Before that, we have to see one-dimensional relative velocity. Everything we observe is called an event in physics. The tick-tick of a clock is an event. Motion of a car is an event. Emission of light by a source is an event. So everything we observe, we call it an event in physics. The place from where we observe the event is called frame of reference. When you observe a moving train from a platform, the train is the event and platform is the frame of reference. When you observe a train from another train which is also moving, then the first one is the event and the second train is the frame of reference. By relative velocity, we mean velocity of a body as we observe or as we measure or as we feel when we stand on our frame of reference. See, here A is a car moving with velocity VA. B is another car moving with velocity VB along a common straight path. Suppose we want to measure what is velocity of B relative to A. Here B is the event and A is the frame of reference. What are the steps to do? We must bring the frame of reference to virtual rest. Then only we can say what velocity of B is with reference to A. So the first step is bring the frame of reference to rest, not by breaking. Only in imagination we are bringing the car A to rest. This is why it is called virtual rest. So what is to be done? The car A we are sitting in the car A and we observe running of B. A has the velocity VA. If it is to be brought to rest, just you add a velocity equal in magnitude to VA but opposite in direction. So you add a velocity VA in the opposite direction. Now the resultant velocity of A is VA minus VA, that is 0. That means we have brought this car to virtual rest. The should not be any partiality in physics. So you have to add the same velocity to the car B also. Then now B has two velocities, its original velocity VB in this direction and the newly added velocity VA in this same direction. Now the velocity of B is, these are opposite in direction, so resultant velocity of B is V equals VB minus VA. This is the velocity observed by an observer or by a man in the car A, and this is called velocity of B relative to A. It is written by the using the symbol VB/A. VBA equals VB minus VA. Likewise, suppose we have to observe velocity of A relative to B. Here A is the motion of A is the event and B is the frame of reference. What is to be done? You bring B to virtual rest and observe what is the velocity of A. To bring B to rest, what must be done? You add VB in the opposite direction of this VB. Now resultant velocity of B becomes VB minus VB0. Same must be done to A also. So A has now two velocities, VA in the original velocity and the newly added velocity VB. Now the new velocity or resultant velocity of A is VA minus VB. This is the resultant velocity of B, A relative to B, and is written as VAB equals VA minus VB. This is the basic of one-dimensional relative velocity. So the steps are: 1. Bring the frame of reference to virtual rest. What must be done to bring it to rest? Virtual rest must be done to the object under observation. Then you find the resultant of that, and that is the relative velocity. This is a case of one dimension. We will discuss two dimensions in another posting. Now let us see what is Doppler effect in sound. Doppler effect in sound is nothing but the frequency received by a listener when there is a relative motion between the source of sound and the listener. As a simple example, suppose this be a source of sound. Let its frequency be 10. As a simple example, a sound of 10 Hz is infrasonic. We can't hear it, but for the time being, I take it as an example. So frequency of this source 10 means 10 waves, sound waves, are moving from the source through the space, one behind the other, as a train of waves in 1 second. Suppose a listener, a boy, stands here and he receives the waves. If he is at rest, 10 waves will strike his ear in 1 second and he hears a sound of 10 Hertz. There is no change. But suppose the boy runs towards the source in half a second. Then he is receiving the waves at his own will before reaching his ears as he stands there. He goes to the source and receives the waves in advance. So these 10 waves are moving as a train, and he moves this much distance in half second. That means all these 10 waves will enter his ears in half second. That means at that rate he will receive 20 waves in 1 second. Or he hears a sound of frequency 20 Hertz. That is double the actual frequency of the sound. The same will happen if the source approaches the listener. Then also he will receive a frequency higher than the actual frequency. But what happens if he moves away from the source? Then he will receive lesser waves because he is escaping from the source. And the number of waves hitting his ears will fall, and he will hear a sound of lower frequency or frequency lower than the actual frequency. This is the essential of Doppler effect. Let us derive a formula for this apparent frequency or Doppler frequency. So this is the source moving with velocity Vs. V is the velocity of sound. The listener is also moving with velocity VL. We have shown all these three vectors in the same direction. So when special cases arise, you should give sufficient sign to the velocity values. Now, F is the actual frequency of the sound emitted by the source. Now, what is the velocity of sound relative to the source? Velocity of sound relative to the source, as we have seen earlier, that is relative velocity of sound with respect to the source is V minus Vs. V minus Vs. Then what is the wavelength? We call it as apparent wavelength. Apparent wavelength, V equals F lambda. There is a basic formula connecting velocity of sound, frequency and wavelength. So here apparent wavelength equals velocity by frequency. That is V minus Vs by F. F is the actual frequency. Next step, what is the velocity of sound related to the listener? Because he is the man who receives the sound. So his velocity of sound relative to the listener will be V minus VL. So that apparent frequency or frequency heard perceived by the listener, F dash equals the new velocity by the wavelength from the source. That is V minus VL by lambda dash. Lambda dash is V minus Vs by F, or F dash equals F into V minus VL by V minus Vs. This F dash is called the Doppler frequency or apparent frequency. F is the actual frequency. You can rewrite it as F dash into V minus Vs equals F into V minus Vs, or F dash by V minus Vl equals F by V minus V, V minus Vs. Okay, is it correct? F into V minus Vl equals F dash into V minus Vs. Okay, you can use a mnemonic to remember, as an aid to remember. Mnemonic as an aid to remember. This is, you call this term as the apparent listener. That means apparent frequency by relative velocity. Here you use VL, velocity of the listener. This is the apparent frequency. Both come on the same side. So apparent listener equals actual source. Actual source means actual frequency by V minus velocity of the source. This is a mnemonic or a useful aid to remember the Doppler frequency. Another point regarding Doppler effect is that Doppler effect is perceivable when velocity is parallel to both velocities are parallel. If the velocity of, suppose velocity of the source is inclined, then it can be resolved into two components, Vs cos theta and Vs sin theta. This component won't exhibit Doppler effect. Only this component exhibits Doppler effect. That means when you calculate Doppler in the formula for Doppler frequency or apparent frequency, you use Vs cos theta in the place of Vs in that formula. That is an important point. We will see the problems, various types of problems, light problem, hard problem, extra hard problem, and so on. Thank you a lot.